Okay, good evening. Good evening. Can you hear me? Yes. Okay, give me a minute. Give me a minute. Okay. Now okay? Can you hear me? Now okay now. Now you can no? Okay. Please send me message now. Okay. Okay. What we discussed last day. Today actually we're going to discuss about very important part of this lesson. Therefore, throughout this lesson, keep your focus very well to understand all lesson. Wait. That's a problem. Okay, now okay. Now no problem. Okay. Uh, we Now we are discussing about the extraction methods. I told in this lesson, throughout this lesson, we discussed main three parts. Our target of this lesson, extract uh, extract any compound, any secondary metabolites. You know that in this lesson, natural products are what? The natural products are the organic compounds. Organic compound producing any organism using as a starting material carbon, hydrogen, oxygen, nitrogen plus sunlight. Using this, they as starting material, the plants or whatever organism produce compound we called as natural products. Then natural products we divided into two parts. What? The primary metabolites and secondary metabolites. Yesterday also we discussed about what are the definitions and what are the differences. Now our target of this lesson, I told in this lesson we're not going to discuss about primary metabolites. Primary metabolites we're not going to discuss. Only we discussed about secondary metabolites. Okay. In this lesson, I told the primary metabolites are produced in large quantity in organisms. The primary metabolites produce in large quantity, but the secondary metabolites are produced in very small, very tiny amount only. That's why for medicine production, for medicine production, medicine production, and cosmetic industries, cosmetics, and whatever other different types of, not only them, uh, different types of lot of industries. They are the main industries, cosmetics and medicine. They are the main. Not only that, there are more industries importing these secondary metabolites. The secondary metabolites are produced in plant or whatever organism in very small amount. No, we discussed. They are produced in very small amount. Then what to do? In this lesson, we discuss In this lesson, we discussed how these secondary metabolites, how these natural compounds, very tiny compounds, how we extract, and how we identify this compound. After identified, how we uh, purify, uh, removing impurities, how we purify these compounds. Okay, that's the main target of this lesson. Okay, the other main target, I think you remember, we discussed everything. I just explained the things we discussed up to now. Then I told in this lesson we discussed main three parts. They are uh, the first step is extraction. I think you remember the natural product extraction. The natural product extraction. Natural product extraction. The natural products extraction. What are the extraction methods I told last day? What are the extraction methods? I already discussed last day two methods. What are the methods? Extraction methods? Quickly. Okay, what are the extraction methods? Answers. Natural products or secondary metabolites extraction. Spellings wrong. Extraction. Extraction. Okay. Okay. What are the extraction method we discussed? There are no answers. Why? What's the problem? What are the extraction methods? Yeah, extraction by solvent extraction. Very good. Pressing with wax and distillation. Others, you also need to do answers. Okay, very good, Amar. The first one is the first extraction method is extraction by solvent extraction. The solvent extraction. The first one is solvent extraction. Solvent extraction. The second one is what? The extraction by pressing with wax. Extraction by pressing with pressing with wax. With wax. The extraction by pressing with wax. The third extraction method is distillation. 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 Okay, remember these names. They are uh, always coming MCQ questions, essay questions. Therefore, keep these terms, keep these names, remember very well. Okay, then we have three extraction method. But solvent extraction, extraction by pressing with wax, and distillation. After that, we discussed the, I think, do I given the summary of the lesson last day? Given, no? The full summary, the extraction method, identification method, separation and identification method, and purification methods I given, no? Yes or no? I given chart, no? Yes or no? Yes or no? Is I given chart? The extraction method, they are the extraction method we discussed in this lesson. identification, separation and identification process. Separation and identification process. Identification process. I given no? Yes. Separation and identification process method. What are the separation and identification? We mainly use chromatography. Today we're going to start about chromatography. Therefore, keep attention. Okay, the first chromatography method is paper chromatography. I think you remember the paper chromatography. Chromatography. The paper chromatography. The second chromatography method is thin layer chromatography. Thin layer chromatography. TLC. Thin layer chromatography. Thin layer chromatography. Okay, the final chromatography type is column chromatography. Column chromatography. Okay, chromatography. The mainly we use the chromatography for identification and separation process. The method is chromatography. After that, we have purification method. After that, we have purification method. The third step is purification. The purification means extracted secondary metabolites we identify in the second step. Okay, we identify. After identify this compound, we purified by the purified cleaning. Okay, cleaning by removing impurities by the purification process. In the purification, we have three methods. What are the purification methods I given? Uh, the first purification method is uh, recrystallization. 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 The second one is distillation. Distillation. The final purification method is the final purification method is what? The final purification method is sublimation and deposition. Sublimation and deposition. Sublimation and deposition. Okay, that's a whole summary of this lesson. Okay, I told if we complete these 9 practicals, if we complete these 9 processes, this lesson is 90% is complete. 90% of the lesson is complete. Okay, now last day we discussed about solvent extraction. Do you remember solvent extraction? Now answer, otherwise I am boring. Do you remember solvent extraction? Extraction by solvent? Okay. Others all remember? Then if I told a special method, if it is the solvent extraction like Ayurvedic medicine production, no, like kasaya. Okay, I told we first of all select suitable solvent and place the plant material or whatever uh, plant source in the on the in the solvent, and we heating this solution, and while heating the compound in the plant material come to the solvent, then we can prepare the crude solution. That is the solvent extraction simple method. But That is a batch method, no? That's a batch method. Okay, that's a batch method. The batch method means this thing, this solvent and the this solvent and the plant material, the plant source contact only one time. Only one time it's contact. But if it is in this case, in this process, I told there is a huge disadvantage. What is the disadvantage of this batch type solvent extraction method? There are possible question I asking. I already discussed the lesson. I asking possible MCQ questions. What is the main disadvantage of the batch type solvent extraction method? What? What's the main disadvantage of the batch type solvent extraction method? Inability to extract maximum amount of substance. Yes, good. That means if this solvent not dissolving the not dissolving well this compound on the plant material, if it is this compound not completely not perfect dissolving in this solvent, the maximum amount of compound we can't get for the solvent. The maximum amount of compound we can't get for the solvent. Only one cycle can get, and the impurities are high. No, impurity is a different story. The main disadvantage of in this batch type adhesion, the main disadvantage is only one cycle. Therefore, the some compounds can be remain in the plant material. In the second step, I'm not going to explain step by step here. In second step, we remove this plant material and we only doing other processes for solvent only. Then we consider maximum amount of compound dissolve in the solvent. But this compound is less dissolving solvent. With this plant material, with this plant source, lot of compounds are wasted. That's a disadvantage. That's the main disadvantage of these batch type methods. To overcome this disadvantage, overcome this problem, what we can use? What we can use? What is the method? Name I ask you. What's the method? To overcome this batch type problem, batch type solvent extraction, what is the system we can use? What is the method? The what? Very good. Others? Very good. Now, still we discussing last day. Okay, I'm asking today. I want to show you some practical. That's right. If not, I go to the next one. I want to show you some practical. Okay, that is Soxlet extraction. In the Soxlet extraction, do you remember the how to do Soxlet extraction? The Soxlet extraction, do you remember the natural product? Give me a second. Okay. Okay, now can you hear me? Yes. Okay. In this solvent extraction, do you remember what is the structure of the, what are the working principle of the solvent extraction? Yeah, this is the structure of the solvent extraction. This is the structure I told. This is the solvent. This is the solvent. Just again refresh. Still last day lesson we discussed. This is the solvent. This is the solvent. And this is the solvent chamber. And there is a heater here. Then the when the heater is on, when the heater is on, in this red line, red path, the steam is transfer. Steam is carrying on the red color path. Then after that, it come to this chamber. This vapor come to this chamber. When increase the pressure of this chamber, what happened? The vapor try to go up through this condenser, Liebig condenser, through this Liebig condenser. In this Liebig condenser, I told it has a continuous water supply, water in and continuous water outlet. Therefore, always this Liebig condenser is cooling. Okay, always this Liebig condenser is cooling, always cooling, because continuous water supply and water outlet. Now, what happened? This vapor cooling, what happened? It is condensation. Because of this cooling process, solvent vapor convert into solvent liquid again. Okay, solvent liquid again. I will draw the liquid in blue color. Then again this liquid come to the plant material. This is the plant material available. uh, Paper plant material available, paper cup. Okay, that's a paper cup. Now you can see in the practical, that's a paper cup. And that's we called as soxer, sorry, that we called as uh, that we called as siphon tube, sorry, that we called as siphon tube. When this the liquid level come to this u pipeline, come to this line, just directly at the within few seconds, the whole liquids come to the solvent chamber again. That's the working principle of the uh, uh, Soxrut extraction method. And what is the main advantage? What is the main advantage of this Soxrut extraction? If it is asked like this, is exam asked, what is the main advantage of this Soxrut extraction? What? How you can write? Yeah, answer. Then you can try. You understand. You can check you understand. What is the main advantage of this Soxrut extraction? Yes. Good. Others? Others, what are the advantage of this Soxrut extraction method? Since the plant material and the solvent come into contact several times, yes, high extraction is possible. Very good. That's a circle process. That's a refluxing process. Refluxing means again. That's a circular process. Because of that, maximum amount of compound we can get to the solvent. The maximum, okay, can extract the solvent without uh, impurities. That's not the main advantage, Shivan. That's not the main advantage. The main advantage is they get maximum amount of compound into the solvent. That's the main advantage. Other than the less impurities and other advantages, the solvent and sorry plant material plant material and solvent vapor is contact. I told the solvent vapor temperature is higher than liquid. Okay, therefore that's also a advantage to get maximum amount of compound into the uh, solvent. Okay, the other advantage. What is the disadvantage of this solvent extraction method? Disadvantage, main disadvantage. What's the main disadvantage? Quickly. What's the main disadvantage of this solvent extraction method? Main disadvantage. The main answer. Yeah, if you wrong, no issue, then you can correct. You can. Yes, this very good, Amar. This method we can't use for essential oil like volatile compound extraction because in this method the plant material we heat into higher temperature. Okay, therefore volatile compound we evaporating. If we try to separate by extract by this method we can't use for volatile compounds. Okay, very okay. Now moving to substrate extraction. Okay, this is the heater. If I sorry. Okay, this is the heater we use for this substrate extraction. This is the heater. This is the heater. The heater is that's the electric heater. We can plug into the uh, we can plug and switch on. We can adjust that according to our height required. We can adjust this heater. Okay, that's a supporter. Okay, supporter we need to join for the connect required instrument. Okay, that's a solvent chamber. Okay, that's a solvent chamber. Solvent chamber. Okay, that's a heating support. Heating support. Through this, through this, wait, through this. First, this heater is heating. After that, this part heating and this heat energy supply to the solvent chamber because solvent chamber is a round shape, no, round bottom. No? Therefore, we have to use a supporter. Okay, that's a support. Okay, so that's a funnel. Then that's the solvent. Solvent we fill into the solvent chamber. Okay. Okay, that's a That's a filter paper cup. That's a filter paper cup. The plant material we put into this filter paper cup. Okay, filter paper cup. This is a plant material. I told to increase the surface area, the plant material need to cut into small pieces. Cut into small pieces. Cut into small pieces. Okay, that's the vapor transferring tube. That's the vapor transferring tube, and the second part of the system. That's the and the this is the yeah. You can't see the siphon tube. I will show you. This is the Liebig condenser. You can see this is the Liebig condenser. Liebig condenser. Liebig condenser. It is given coil condenser. It is in your syllabus. It's given as Liebig condenser. Okay. Then this is water supply line and water outlet line. Okay. Water supply and water outlet line. Then we'll see what to do. Okay, the upper line. See carefully. The upper line. Okay, sorry. Okay, see again. The upper line, this line, we need to put into a sink or whatever outlet. Okay, that's the outlet. We need to connect to a whatever water outlet source. Okay, then the lower line we need to connect into a pipe, the water coming source. Then we switch into after the now you can see water is filling the condenser and the additional water is go out from the condenser. Okay, sorry, my battery is low. Give me a second. I'll start. Give me a second. Okay, sorry. Okay. Okay, where we discuss. Okay, then we on switch on the heater. Then you can see rapidly heating. Rapidly heating. Okay, that's according to our requirement. We can adjust the temperature. Then the solvent is start to vaporize. And the solvent go through the solvent transferring carrying line, and it's come to this chamber and go through the condenser. Then after go to the condenser, you can see again these liquids come down. Again this liquid come to the plant material chamber. Okay. Okay, that's a siphon tube. That's a siphon tube. That's a siphon tube. That's a siphon tube. If I That's a siphon tube. That's a siphon tube. You can see that's a U shape. That's a siphon tube. Okay. Okay, we'll see what happened by the siphon tube. Okay, wait, now it is filling. This chamber is filling. Continuous filling. Continuous filling. Sorry. Now it is, see again. Now it is, sorry. Now it is continuous filling. Okay. After the water level, solvent level, come to this point. This point, see carefully. That is the siphon process. It's rapidly come to the solvent chamber. So siphon. Then again start to fill. All solvent in the chamber come to the solvent chamber. From above chamber to solvent chamber. See again, that's a siphoning process. Siphoning process. All solvents in the above chamber come to the solvent chamber rapidly. That's the okay. Then we can again adjust the after all cycles complete. We can remove the heater and we can get the solvent and go to our other processes. Go to our other processes. Okay, are you understood? What happened? Any doubt? Any doubt? Others clear or not? That's the solvent extraction by uh, Soxhlet extraction method. Solvent extraction by Soxhlet extraction method. Okay, now send me clear or not? Only two. Send me clear. Arshad, clear? Okay. That is the solvent extraction by Soxhlet extraction special method. Now we move into our second method. I told again, I refresh that second method, the extraction by pressing with wax. Extraction by pressing with wax. Okay. Okay, I will explain rapidly what is the extraction by pressing with wax. For this method, first of all, you need to select same size two glass plate. As I told last day, you need to select same size two glass plates. Okay, same size two glass plate. Then first of all, and in the laboratory, I told in the laboratory you can find the paraffin wax powder. Paraffin wax powder you can find in the laboratory. Okay, you need to get paraffin wax powder some amount and we need to heat that. While heating, what happened? This paraffin wax powder convert into a paraffin melting, no? Melting, you already know. They are melting, then convert into liquid. After that, we need to get this glass plate and think this is a glass plate. Think this is a glass plate, and we need to add some paraffin wax, and we need to prepare a very thin layer on this, very thin layer on thin wax layer on this glass plate. Okay, after that we need to keep some time in normal temperature, then it's become solid. It's become solid. Okay, after that, samely, the second glass plate also you need to prepare a thin wax layer on this thin wax layer on the glass plate. Okay, after that, what I told, we have two glass plate with wax. After that, we need to get the plant material. The plant material means the volatile compound available plant material normally we use, because other separation, these other secondary metabolite separation, these uh, par, uh, paraffin wax method, not normally we not going to use, because more than that, other methods are easy, because for this method we need 48 hours, for 24 to 48 hours. It's a time taken process. Therefore, we can use other method, but in other methods, the volatile compound, essential oil, we can't separate. The reason is what? They are volatile, easily evaporate. We can't heat. Okay, therefore, we after we prepare a thin layer on this glass plate, thin layer. In second one, as I told last day, if we select rose flowers, the rose petals we can lay on this wax layer, both wax layer we place on this wax layer, entire wax layer cover by rose petals. Okay, rose petals. Okay, after that, this one glass plate and other glass plate, the two layers we need to keep together. Then we need to pressure that by clip or whatever, rubber band or whatever method. We have to pressure up to 24 to 48 hours. Okay, we need to uh, pressure it 24 to uh, 24 to 48 hours. We need to pressure that. We need to pressure that by uh, tightening this to wax layer. 24 to after 24 to 48 hours, after 24 to 48 hours, after 24 to 48 hours, 24 to 48 hours, what do you need to do? We need to remove this glass again, separate this glass, and this wax collect into a beaker. We need to remove this plant material, rose petals we need to remove, and we need to collect this wax, we need to collect into a beaker. That's a wax amount. We need start and we can uh, collect into a beaker. Okay, collect into a beaker. After that, what I do? Do you remember what's the next step? We need to add some amount of ethanol here. Ethanol we need to add and uh, heat this very carefully. We need to add some amount of ethanol and heat this beaker very carefully up to until this wax is become solid. Sorry, wax is become uh, liquid again. I need to convert this paraffin wax powder again, paraffin wax crystals actually now. They need to convert again into liquid form. Okay, melt. Okay, after that, what happened? This all ethanol, paraffin wax, and compound in this paraffin wax convert as a same solution, same solution. After that, after that, again this beaker need to cool. Again need to cool. Again in this here heating, heat carefully and melting the solution. Heat carefully and melting the solution. Then it violate. We completed practical. So Okay, after heating all this solution, okay, uh, watch this video. We discussed practicals as well. Okay, need to after add ethanol carefully. This need to heat entire solution until this wax is melted. Wax is melted. After that, this all solution become as a same solution. After that, we need to cool this mixture. After cooling, this wax layer again convert into a solid. Again convert into solid. Wax again convert into solid. Then the ethanol and compound go into the upper layer. That's a solution. Ethanol and upper layer. Sorry, ethanol and compound come to the upper liquid. Upper this liquid. Okay, then we can separate this ethanol and compound. If we want, we can again heat this carefully, and we can remove some part of ethanol as well. Okay, again we can heat in very carefully. We need to careful while we heating, because the compound is a volatile. The compound is volatile. Therefore, we can't as 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 our as you wish. You can't as any temperature. You can't heat this. You need to carefully uh, control the temperature, and we can heat and remove some part of ethanol. All ethanol we can't remove. Then after that, remove ethanol, we can produce the crude product. This is the crude product. This is the crude product. That's a crude product. The crude product mean what? The crude product mean it's not the PO, the compound and impurities in this crude product. Uh, Crude product mean the uh, compound with impurities, not the solid. The final product is not purified. That's why we called it as a crude product. Okay. Any doubt in solvent extraction by pressing with wax? Actually, we discussed last day. I just explained for your further understand. Okay, better. The most important thing is while you read note and try to remember, that's not good. Okay, the better thing is if you can prepare a short note in this type, this lesson and industrial chemistry, polymer, and in our all other lessons. All in future we need to discuss lessons. Future we discuss lesson. Better to prepare a perfect short note without taking time at the same week. Okay, after we discuss today part, you can complete short note for today part. Then you can easily remember this process, and that's not a bulk. If you take this lesson into a very short few page, then it is a very simple lesson. Okay, then for exam, that's not a they are not a heavy lessons. They are very simple lesson for at the when close to the exam. Okay, can we go for distillation? Up to now, are you okay? Up to now, clear? Amar, up to now, clear? Any doubt? Arshad. And who is for Mohammed? Mohammed clear? Okay. Okay. Come to the the third extraction method. Come to the third extraction method, very important method. The third extraction method is the distillation. Distillation, as I told earlier. Do you remember? Sorry. The solvent extraction we discussed with practicals now. The extraction by pressing with wax, I found a video, but I couldn't find. I will try to show you a perfect video for extraction by pressing with wax. Now we discuss distillation and distillation practicals. Okay. The pressing with wax, you can understand. No, that's a simple process. Pressing with wax, in the name also explain the process. Okay, pressing with wax and separate volatile compound. Okay, now we go into the distillation, our third topic, the distillation. Distillation, the third and final extraction method. Third and final extraction method, distillation. Okay, the distillation, mainly three type we going to discuss. Actually, in this in our tude, not given much information about distillation. Therefore, better to draw figures than that enough. Actually, the distillation is very simple. Okay, the distillation mainly three types. What are the methods? The first one is simple distillation. Simple distillation. The simple distillation. The second one is steam distillation. Steam distillation. Steam distillation. The third one is fractional distillation. Fractional distillation. Fractional distillation. Okay, go to the tube first before we start. Go to the tube. Go to the tube. Tube page number. Yeah, we discussed now 50% of the lesson is completed. Now we discussed pressing with wax, page number 10. Steps also given. Extraction by distillation, page number 10, the bottom part. The distillation done in three ways. The mixing with water and heating, that's a simple distillation. The tube given. Mixing with plant material with water. Actually, the water is one solvent. It should be the mixing with plant material with a solvent. That is a perfect way. The mixing with plant material with solvent and heating. That's the simple way. That's a simple. That's actually simple. That's why we call that is simple distillation. The simple distillation is like this. Understand very well. Then anything you don't need to remember. Only understand enough. Okay. The first distillation method, simple distillation. Simple distillation. The simple distillation. Simple distillation means very simple. It's like this. Okay. The simple distillation means, think this is a round bottom flask. Round bottom flask. and this is the solvent. This is the solvent. Round bottom plus solvent. This is the solvent. Whatever same the solvent, you need to find a suitable solvent according to the we discussed the polarity. Last day we discussed polar solvent, non-polar solvent, medium polar solvent. According to the polarity, you have to find a suitable solvent in this as this solvent. Okay. First of all, need to take a round bottom plus, round bottom or whatever. Normally in practical we use round bottom plus. Okay, round bottom plus, and for this point at the open end, we need to contact with a Liebig condenser. Liebig condenser. Liebig condenser. That is the simple distillation. Actually simple. The simple distillation means actually it is simple. The simple distillation means actually it's simple. Then this, it should be water in. Water in. It should be water out. Water out. Then the plant material, it is a plant material. We need to cut into plant material, cut into small pieces and add into the round bottom flask with the solvent. This is the plant material. Plant material. Plant material. Okay, draw this figure, then easily you can remember. I will show you practical as well. Draw this figure in, I think you don't have space. You can use additional paper. In your short note, you can draw. Yeah, it's better. In your short note, you can draw. The plant material. Plant material. Okay, this is the plant material and solvent in the round bottom flask, and the upper open end of the round bottom flask, we need to connect with the condenser with continuous water supply. Continuous water supply and outlet. Then you can find, you can actually, now I don't need to explain the process, no? First of all, what happened? We need to heat that, and here heater, I forgot. That's a heater. Heater. That's a heater. Okay, same as previous. We need to switch on the heater. Then what happened? The solvent is start to vaporize. The plant material in the same chamber. Therefore, plant material and solvent contact each other, and compound in the plant material first go to the solvent, and this solvent is vaporized. Solvent is vaporized like this. Solvent is vaporized. After this solvent moving in the transfer to the condenser, the condenser is always cooling. The condenser, Liebig condenser, Liebig condenser, the Liebig condenser. The Liebig condenser mean, actually the Liebig mean the scientist name. The Liebig is the scientist who has found this condenser. That's why. Okay, the Liebig condenser. Okay, then okay, that's the water. They are water on this surface. It filled with water. That's why the vapor on vapor in this condenser quickly cooling and convert into what? Convert into cooling and convert into liquid. Convert into liquid condensation. Then it's collected to the this final beaker. That is the fruit product. That's the fruit product. That's the fruit product. That's the crude product. Okay, are you good? Are you got the process? Tell me all. Any doubt in the simple distillation? Very simple. I think in the O-level time also you already know the simple distillation. Quickly send me. Are you okay? Are you good? Okay, quickly draw this and the process. I think you can easily remember. The solvent is heating, then compound in the plant material come to the solvent because of high temperature. Then solvent is vaporized. Solvent vapor uh, while moving while transferred through the condenser, it is cooling and condensation. Then the condensed liquid solvent liquid come to the final beaker. That is the crude product. This what are the compound in this crude product? It contain the solvent plus compound, solvent plus compound plus impurities. That's why we called as it as a crude product. It has impurities. Okay. Okay. Complete drawing. If you complete, send message. Compound. So in the exam, will they ask the method and steps of each? Will they ask method and steps of each? Yeah, only one time they have asked. I think Deneth, you did this question in the Sunday. No? Only one time they asked what are the basic steps of the recrystallization. Okay, still we not discussed but they only ask A to Z the full process not asking, but they can ask briefly explain the basic steps of the simple distillation. This type question possible. Okay? The simple distillation, basic steps of the simple distillation you should able to explain. Now the basic steps you can explain. No? That's a simple process. If you remember this figure, they don't need to by heart. If you remember this figure, then you can think and you can write in your word this explanation. No doubt, no issue. But only definition you need to write down with keywords. Explanation, no worry. You explain for explanation. You don't need to worry. You can explain in your word, but your explanation should be short and correct. Don't go into briefly. I will discuss in the paper discussions. I will explain. If they given briefly explain, you need to mention your answer. You need to provide your answer within 2 to 3 rules. 2 to 3 rules. If they given explain, the steps of simple distillation, now you have to explain this with like a small paragraph. Don't like 2 to 3 pages. Okay, don't write. They're not going to read there. Okay, therefore your answers should be you need to write into the point, and you need to complete your answer very short form. Okay, in our lessons, in I think our engineering technology, you have some long answers, no? But in our I will discuss I will explain in the paper discussions in Monday. You have to answer now. Just we start only structured on for next exam. You have 4 structured essay, and next exam is the full exam. Therefore, get ready for that. Your next month exam. It will held second week of the next month. The second week mean second or first week before 10th of June. You have to face a full exam. It has 50 MCQ, 4 structured essay and 4 essay. No selection. You have 5 hours. 5 hours mean the first day you have only MCQ paper, only 2 hours. Okay, I think it's better if I give an MCQ and essay both. You only focus into the essay and structured essay. It's not good. The MCQ paper also 50 marks. Other 2 paper also 50 marks. Then you need to actually the MCQ is the most easy way to get marks. If you mark 1 MCQ correct, you have 1 mark. To get the 1 mark from essay part, the second part, you need to write many answers. 3 to 4 answers you need to write correctly to get 1 mark in the second part. But if you mark 1 MCQ correct, you have 1 mark from 100. Therefore, MCQ is very important. Therefore, I hope to the second exam, in the first day you have only MCQ paper. It's only 2 hours. After in the second day you have structured essay and essay paper. I think it will we'll try. I think it will be very productive. Amara, are you good? Are you okay? Okay. Okay, I will show you the simple distillation. This is the simple distillation. The simple distillation, the water in and water out from upper end always. That's condenser. That's a simple diagram. And you can see round bottle flask and the heater. And it is a seawater. Don't think that's another process. But I just want to show you the main part of the simple distillation. That is from seawater, pure water separation process. seawater, then only vaporize. Don't think about that. That's not relevant to our lesson. I just want to seawater only vaporize pure water. Then pure water we can separate like this. That's a simple distillation process. Simple distillation process. Okay, that's a simple distillation. Okay, you can see they're not going to use heater. That's a Bunsen burner. Bunsen burner also you can use if you don't have a heater. Okay, if you don't have a heater, we can use Bunsen burner to heating process. Okay, then the solvent is heating and boiling, and after that they are vaporized. Vaporize. You can see the condenser is always cooling. You can see at the after this vapor in yeah, that's also pure water distillation process. Don't think about that. Only understand the process. Okay. At the end, you can collect the crude product. Okay, that's a simple distillation. That's a simple distillation. Any doubt about simple distillation? No. Okay, come to the second one. Second distillation method, the steam distillation. Steam distillation. Steam distillation. Steam distillation. Second distillation method, steam distillation. Steam distillation. Okay. The steam distillation is same as simple distillation, but only one step is different. The same as simple distillation. First, understand the process. That's a round bottom flask, and the round bottom flask, and this is the solvent. This is the solvent, and this is the heater. Heater. This is solvent chamber. Solvent chamber. Solvent chamber. Then this is a vapor carrying line. Vapor transferring line. This line, the thing is only this in simple distillation process, both solvent and plant material in the same container. But in this method, the solvent in a different container. This is solvent chamber only. Don't have any plant material in this solvent chamber. The plant material in a different sum. The plant material in a different container. Okay, they are the plant material. In this plant material, same. Okay, we need to cut into small pieces to increase the surface area. They are common for all methods. Okay, they are common for all methods. Now that's the plant material. Okay, now we need to add This is the line. Okay, this is a solvent vapor carrying line, transferring line. Then we need to get another line here. We need to get another line from okay, we need to get another line from this chamber and connect into a condenser. Okay. Then this is water in line. This is water outlet. This is water in. Yeah. Who is okay? Okay, this is water in. Water in. This is water out. This is water out. Water in and water out. And finally, you can separate. You can separate the crude product. The crude product you can separate from this uh, steam distillation method. Okay, now what happened in this method? In this method, this is the solvent in the first round bottle flask. In the first chamber, only solvent. Don't have any plant material. Okay, only solvent. Then what happened when on this heater, the solvent vapor go through this line. Solvent vapor go through this line. Okay, now the solvent vapor coming to the second chamber. In this second chamber, the small pieces of plant material and solvent vapor contact together. After contacting, they are contacting. After contact, they go through this line and go through the condenser. The condenser has a continuous cooling process. Therefore, after that, the condensation convert into liquid and go to the uh, crude product uh, chamber. That's the finally we can separate crude product. Crude product. Understood? This is a plant value. Okay, draw this and name this label that. Then you can, if you remember the figure, that enough of this part. That's why I not given any process explanation. These are don't need to remember as by heart knowledge. Don't need. If you know if you can remember the figure, that enough. Plant material. Plant material. Amar, understood? Okay, draw this. Complete. Tell me. Have you done? So, how do we determine which type of distillation is suitable to extract certain compound? Okay, good question. I will explain. Okay, complete. Moment, complete. Okay, okay. Okay, if you search in the internet, you can find this type of figures for steam distillation. Steam distillation, this is the, what is that? Okay, this is the solvent, and there is a additional line. What is this? That's a pressure control line. That's a pressure control line. In your diagram, that's not compulsory. If it is high pressure, the pressure cannot retain the chamber. The solvent go through this line into out and control the pressure. That's a pressure control line. And the solvent vapor go through this line. Solvent vapor go through this line and come to the in this one. It's not correct. Okay, that's a water purification process, but in our one don't need this one. This part don't need. Okay, we're not going to heat plant material directly. Only solvent we heat. Okay, therefore don't think about that. Don't think. And the solvent vapor come to the plant material. Think this is plant material. That's a liquid separation process. That's a it's different. Uh, This is plant material, the solvent vapor and plant material contact. Then the contacted vapor go through this condenser and fill to the this good product solution. Okay, that's the uh, steam distillation. Steam distillation.
Before starting your experiment. A common example of this technique is in the extraction of the oil limonene from orange peel. The orange peel is shredded into small pieces and transferred to a round bottom flask. Water is then added to approximately half fill the flask before we clamp it into a heating mantle. We connect a Kleisen still head to the flask, which has two necks, allowing us to place a dropping funnel in one of them to add more water as the steam distillation proceeds. As we don't need a thermometer to measure the temperature during the distillation, we've placed a stopper in the second neck of the still head. In some cases, a splash head may be connected at this point. Here we have a condenser with water running from bottom to top, and after the condenser, we have a receiver running into a conical flask. The water in the flask boils, generating the steam required for the distillation. We can maintain the level of the water throughout the distillation by adding more of it in small portions from the dropping funnel.
Yeah, this is not relevant to ours. However, Yeah, it's not. That's also a steam distillation, but it's not our one. It's a different process. Okay, I think now I will show you. I'll find an video and I will show next day. What is a steam distillation full video? I will show. Uh, okay, there are the steam distillation. Steam distillation. There is a process and how this steam distillation is work. In the you can search in the YouTube or internet. The steam distillation, lot of other purposes come in. That's a problem. The uh, say, extraction is not available. I will find more and I will show you. Okay, come to the final one. The final distillation method. Uh, final distillation method. The final distillation method. Fractional distillation. Fractional distillation. Fractional distillation. Fractional distillation. What's the meaning of the fractional distillation? Do you know the fractional distillation where you meet what you have, what you heard about this fractional distillation? Do you know crude oil? Crude oil. What are the crude oil? Crude oil. Crude oil mean boratel kin. That's a crude oil. Normally, this crude oil, from this crude oil, separate butane, propane. The butane, propane mean the your home use the gas. Yeah, mix of all the oil. No, the mix, not mix of all the oils. The uh, from this the crude oil is a energy source in the ground, the in the earth, energy source in the earth. Uh, from this crude oil we can separate butane, propane is first separate, and after that petrol, diesel, um, what oil types are the engine oil like, and we can separate. Finally we can grease and other everything is produced. Every products are produced by the um, crude oil. This crude oil separation, the crude oil separation method is the fractional distillation. I think in uh, the fractional distillation, the fractional distillation is the crude oil separation process. Crude oil separation process. Give me a second. Okay, that's the, you can see this is the crude oil separation process. The for this fractional distillation, we need to use the special type of column, and sometimes we use uh, more than one condensers as well. More than one condensers. Then you can see from this crude oil. This is you can see this is a crude oil. That's the source, and from this crude oil you can separate butane, propane. That means gas, the petrol, kerosene, diesel, and fuel oil. Finally, you can the grease and grease produce. Finally, the uh, remaining is the grease. Okay. Okay, you can, if you search, you can find different types of fractional distillation process. Fractional distillation process. For this, yeah, you can see. Okay, for our lesson, we discuss this type of fractional distillation process. For this fractional distillation, first of all, we need to place our plant material and solvent in the solvent chamber. Okay. After that, we need to heat, and there is a yeah, what's the name? The fractionation uh, column. What's the correct? There is a this fractionating column. Okay, there is a fractionation column. In this by this fractionation column, we can separate. That is a fractionate. The fractionate means separation. In our lesson, you need to remember. Think as example, same one plant material. Think example, cinnamon leaf. Cinnamon leaf. Cinnamon leaf. Cinnamon leaf has two plants. Cinnamaldehyde already available, but think one vasicine or whatever, two or three compound we need to separate from one plant material. Then in this case, in this type cases, if it is more than one more than one compound, if need to separate from one plant material, is this in this case we have to use this fractional distillation by the fractionating column. The fractionation column is the separation is the purpose. Okay, the separation is the purpose of this fractionation column. According to the density, we can separate. After that, using condenser or without condenser, we can separate them. But in our case, we need to separate. We need to use condense because we need to get the crude product. No? Okay, this is the distillate. Finally, the crude product, that's a distillate. Okay, therefore, just only remember the parts. Remember the parts. This is a fractionative column. This is fractionative column. The purpose is separate compounds. Separate compound that we can extract by this fractional distillation method. Fractional distillation method. You need to remember very well this fractional distillation. Not asked. No any questions asked up to now. Only simple and steam distillation I have asked. Only you need to remember the fractional distillation we use if need to separate more than one compound from same one plant source, plant material. Okay, in this case we can use the fractional distillation. Okay, better draw this in your book, in your short note. Okay, I will draw that. Don't need all names. Only remember few names. Okay, this is the fractional distillation. This is the solvent and this is the solvent. This is the plant material. And there is a special column here. There is a special column. By that's a special, the purpose of this column, separate the compound. According to the density, we can separate the compound. The column we called as fractionative column. The what are the spellings? Fractionative column. Fractionative column. Okay. Then after that it can be open or closed. Then we can separate using several output. Okay, we can separate using condensers. You can use many condensers and you can separate more than one product. They are condensers. We can use more condensers, not only one. That's a fractional distillation. Normally in the world, that fractional distillation mostly used for the crude oil separation process, the petrol diesel purification process. Okay. I will only go to that. They are condensers and the crude product we can separate more than one compound from one source, one plant source. Understood? Understood the distillation? The fractionative column, the function is separate compound separation. Compound separation is the function of the fractionative column. Okay, that's all about distillation. The distillation. One point I forgot. Very important point. Tell me, when we compare steam distillation and simple distillation, what are the advantage more than simple distillation? What are the advantage of simple distillation? Think and tell me. Yeah, that's a actually exam question. Simple distillation and steam distillation. What are the advantage of steam distillation more than simple distillation? What are the advantages? Solvent get well, collide with the plant product. Yeah, that's the advantage. Good. The vapor of solvent react with plant material at the higher temperature. Good, that's also advantage. But the main advantage, remember and note down that the steam distillation, the steam distillation we can use for the separation of volatile compound. The steam distillation we can use for separation of volatile compound. Is it possible? Is it possible? I told in solvent extraction, volatile compound we can't separate. Why? Even the while heating the solvent, volatile compound vaporize. But remember, this steam distillation we can use for separation of volatile compound. The reason is the volatile compound vaporizing, again after vaporize it go to the condenser and convert it to liquid, and the we can use this steam distillation for volatile compound separation process. And the second point, the purity of the steam distillation crude product is higher than simple distillation crude product. The purity is very high because no any non-volatile compound not come into the crude product. Only volatile compound come. Non-volatile compound cannot separate by the only solvent. Therefore, the purity is very high in the steam distillation. Are you got any doubt on these 2 points? Any doubt? Okay, now tell me, in this simple distillation, the simple distillation, volatile and non-volatile, both compound come to the crude product. Therefore, the purity is low in the crude product. But in the steam distillation, the purity is high because of the only volatile compound come to the crude product. But the purity is high, not only compound. It has impurities, but comparatively purity of high. But the steam distillation also, the collecting product is a crude. The crude product, it has not only required compound, it has impurities. That's why we call it as crude product. Okay, the first one, extraction is completed. The extraction now, okay. You already know three methods. In three methods altogether, the solvent extraction, simple method, batch method, the solvent extraction, continuous Soxhlet extraction method, the uh, third one, the extraction by pressing with wax, the extraction with pressing with wax, and simple distillation, steam distillation, and fractional distillation. Altogether, you six method you know. Okay, the question, sir, what is the reason for higher purity of the end product steam distillation? Higher purity mean that's I told. In the steam distillation, only volatile compound go to the crude product. Non-volatile compound, it's impossible to go. Only volatile compound. If it is the vaporized with the solvent vapor, it should be volatile compound. Non-volatile compound cannot go to the crude product. But in simple distillation, the volatile and non-volatile compound dissolve in the solvent and go to the crude product. The volatile compound directly go to the crude product. Therefore, the purity, comparatively, the purity is high in the steam distillation. Understood? Yeah, that is another question you asked. No, how we find the suitable method. The suitable method we find according to the our requirement and our facilities. Okay, if you need separate only volatile compound, we can go with the steam distillation. If you need to separate only volatile and non-volatile both compound, you can go with simple distillation. If you want to separate more than one compound from one plant material, then you can go with fractional distillation. Now, okay, according to your purpose, the required suitable method you can find. Okay, now come to the separation and identification process. Page number 11. Till page number 11. Purification of the pure product from the fruit extract separated from plant parts. The chromatography is used method for separation. The separation and identification both we use chromatography. The separation and identification both we use chromatography. This method is often used for separate impure fruit into that don't need. There are different types of coloring agents that I will explain in the chromatography explanation. Different compound dissolve stationary. Okay. Stationary in every chromatography paper there is a stationary phase and mobile phase. After discussion, chromatography techniques we can discuss further things. There are three main types of chromatography techniques. The first one is paper chromatography. Note down. There are three types of chromatography types. The first one is paper chromatography, no doubt. The second one is thin layer chromatography. Within bracket, write down and highlight TLC method. TLC method, thin layer chromatography. Short form is the commonly used. In the exam also given, not like thin layer chromatography. In the exam also given TLC method. TLC method. Then you should know it is thin layer chromatography. TLC method. The final one is column chromatography. The final one is column chromatography. Column chromatography. Okay, now understand very well. Can we continue today 9:30? Then two chromatography types we can finish. Then only one will remain that we can discuss. Next day, within next day, this lesson is complete. Then within 4 days. Yeah, physical class we complete this. We completed this within only 3 days. Online we have about 4 days. Okay. Okay. For identification method, you can use three method. Uh, the first one is paper chromatography. The second one is thin layer TLC method. The final one is column chromatography. Now we're going to move into our first one, the paper chromatography. Paper chromatography. Paper chromatography. The paper chromatography. The paper chromatography. For this paper chromatography, very simple. Chromatography, all chromatography types are very simple. Don't need to remember, don't need to read and understand anything. If you understand my explanation, you can get 100% right. Okay, if any doubt, you can ask. Okay, first of all, you need to get in the laboratory, you can find the chromatography papers. In paper chromatography, we have to use a chromatography paper. There is a special name for this chromatography paper that we called as Watchman number one paper. Watchman number one. The Watchman is the scientist who found this. The Watchman number one paper is the name of this chromatography paper. Okay, therefore, your first step should be get a Watchman number one chromatography paper. The size also I have given in the tube. The size is 8 centimeter height and the width is 4 centimeter. 8 centimeter height and 4 centimeter height chromatography paper you have to get from the laboratory. In the second step, you have to prepare a solvent chamber. As solvent chamber, we can use a jam bottle or jam bottle size beaker. You can imagine jam bottle we can use, or if you don't have jam bottle size beaker, not a large one. That's a small beaker we can use. Okay, small beaker. If I draw large one, it is a small beaker. Okay, it's a imagine jam bottle size beaker. Okay, that's a solvent chamber. Okay, solvent chamber. These terms are very much important. Okay, these measurements compulsory you need to remember. Okay, uh, solvent chamber. The solvent chamber. After that, uh, collect your solvent chamber. Suitable solvent. Again, suitable solvent mean what? The suitable solvent mean according to the compound. Okay, according to the compound, according to the polarity. I have explained you. Then a suitable solvent we have to add up to 1 centimeter above from the bottom. Only 1 centimeter we need to add the solvent. The solvent height should be 1 centimeter only. This measurements compulsory you need to remember. The only 1 centimeter height we need to add the suitable solvent that we called as suitable solvent. Suitable solvent. Suitable solvent. suitable solvent. After that, we need to close this using a petri dish, or you can use a glass or whatever cover. Okay, whatever cover in the tube given watch glass, though not watch glass, no? Yeah, watch glass. So whatever glass you can use to close this chamber, close this chamber up to 20 minutes. Okay, but first of all you need to find the, okay, better to change this. First of all you need to prepare the solvent chamber. It's better. First of all you can prepare the solvent chamber, then you can change. Somehow you have to do. Better to get this as one. This is one. Prepare the solvent chamber first. Solvent chamber first. After that, you can come to this one. Then you can easily understand. This second. Okay, what you need to do first? You need to find a jam bottle or jam bottle size beaker. Then suitable solvent up to 1 centimeter add into the beaker. Then close the beaker and keep 20 minutes. Keep 20 minutes. 20 minutes. Keep 20 minutes. This not millimeter, not minutes. Okay. This values in this practical values compulsory to remember. You can't change these values, and terms you can't change. Okay. Therefore, focus very well. First of all, what we did, we prepared the reaction chamber. Okay. After that, the second step, you have to collect a watchman number 1 chromatography paper. Watchman number 1 chromatography paper from the laboratory, and you need to get a very thin pencil. You need to get a pencil with very thin pencil. Get a very thin pencil, and you need to draw a very smooth line on this very chromatography paper. On this chromatography paper, very smooth line. Use thin pencil. Okay, thin pencil, and draw a very smooth line 1.5 centimeter. This measurement is very important. 1.5 centimeter above the lower end. The bottom end above the 1.5 centimeter, you need to draw a line that we called as baseline. Not baseline plot, that's baseline. Baseline. That's the baseline. Okay. After that, using same thin pencil, you have to draw another line, very smooth, another line on this chromatography paper. It should be thin. Okay, it should be thin. It should be thin line. Straight line. Okay, my one is not straight. Okay, straight line. Straight line. On the chromatography paper, 1 centimeter below the upper end. 1 centimeter below the upper end. Understood up to now? We need second step. The first step is completed. Still not 20 minutes. We have to keep it. Okay. In the second step, we need to get the until this 20 minutes. You have to prepare the chromatography paper. First of all, you need to find the chromatography paper watchman number 1. Then this is a baseline 1.5 centimeter above the lower end and 1 centimeter above below the upper end. You have to draw a very thin line. This also have a specific name. This line we call as solvent front line. Solvent front line. This is solvent front line. Baseline solvent front line. Okay, second step complete. You have prepared your chromatography paper. In the third step, now you have to get the already extracted solution, already extracted crude product. Think this is a crude product. This is a crude product I extracted from cinnamon leaves, cinnamon bark. The crude product I extracted from cinnamon bark. In this chromatography method, understand, in this chromatography method, I need to separate, I need to identify cinnamaldehyde available or not in this crude product. What? This crude product is a extracted product from a cinnamon bark. Okay, extracted product from a cinnamon bark. Now I need to confirm, I need to identify this solution, this product, this crude product has cinnamaldehyde or not. Okay, has cinnamaldehyde or not. For that, we need to get the glass rod. The glass rod mean what? In Sinhala, we need to get a glass rod. Okay, the glass rod in like this. Okay, then we need to get a very small sample from the glass rod. Okay, glass from crude product using glass rod, and we need to place on this baseline. We need to place on this baseline. Okay, I will name it as sample number A. Sample A. Small sample I got from the crude product, and I put a very small sample. I name it as A. Then, for identify this crude product, I need the special sample. In the laboratory, you have to find purified cinnamaldehyde compound. Okay, purified cinnamaldehyde compound. Same method, using glass rod. We have to get a sample from the purified cinnamaldehyde solution. Then we need to prepare another column, another point, another sample. That is a control sample. This is the what this name, check-in sample. Check-in sample or what? There is a name, no? In O level, experiment sample. Experiment sample. The A is the experiment sample. The C is the control sample. The C is purified cinnamaldehyde. The A is the experiment sample. This is the crude product sample. Up to now, got any doubt up to now? Still we prepared solvent chamber and watchman paper. Okay. Now, the third step is the third step. Now, the second one is okay. We have prepared the chromatography paper. Now, the third step is after 20 minutes complete this solvent chamber. After 20 minutes completed, after 20 minutes completed, after 20 minutes completed, think this is a reaction chamber. Sorry, the reaction chamber don't mix the reaction chamber make in the next lesson. The industrial chemistry lesson, there is solvent chamber. The solvent chamber. This is the solvent chamber. Okay. Now, this is the solvent up to 1 centimeter. 1 centimeter, that's a solvent. Now, after 20 minutes, close the solvent chamber. We need to just open this solvent chamber, and this chromatography paper, we need to place on this. We need to place in this chamber like this. This chromatography paper we need to place in this chamber like this. Okay, then you can see the baseline is like this and the solvent front line like this. And two samples here you can see. Two samples are there. Then what happened if when you observe the solvent level gradually increasing to this paper. The color of the paper gradually changing as a line. The gradually changing. Okay, when we observe the paper, the what happened? The solvent is go through this line. You can see this if you take a water bucket and if you add a tissue paper. What happened? The water by capillary action, it's come to your hand. No? It is wetting. That same, the solvent go through this, wetting this paper. We can see gradually it's slowly go up the solvent layer. Now when this solvent layer come to the solvent front line. Okay, when this solvent layer come to the solvent front line, we need to get out this. We need to careful. We need to get out this. When come to the solvent front line, just we need to get out the chromatography paper. Okay, then this is the chromatography paper. Finally, this is the chromatography paper. Think this is the chromatography paper with this is the baseline and solvent front line. Baseline and solvent front line. Baseline and solvent front line. And okay, that's actually the process of paper chromatography. Yeah, everything I explained. First of all, prepare the reaction chamber, prepare the chromatography paper, then place the chromatography paper in the chamber, and when the solvent layer come to the solvent front line, just we need to get out the paper. Okay. If this, okay, finally, after we get this paper, the final paper, any difference you can't see. If you observe that, if you think this is a chromatography paper, if you observe that, any difference you can't find. Any difference you can't find. But any difference you can't find. But the thing is, if you use any in the tute I have given, if you use any coloring techniques or whatever visualizing agent, like you can use UV light, and I will explain one by one there. If you use coloring agent or spreading agent or UV lighting agent, we can observe, think this is A sample and this is control sample. We can observe the A sample has like this points, and C sample also has a point like this, Okay, then if there are any compound in same distance, then we can identify this A crude product. This crude product has cinnamaldehyde, has the specific controlled product. Any doubt? This is a story. Then finally, according to the distance, we can identify this A sample, A crude product available or not the specific compound. Are you got? Any doubt? Tell me. Very simple. If you understood, no need to again worry about chromatography. That's all about paper chromatography. Any doubt? Anything you can't understand? Mohammed, clear? Amar, are you good? A and C are from the same extract or difference? No, no. The Chevron, the A is the crude product sample. That you need to identify. The C is the control, purified sample. Think example, this is a crude product. I want to, that's a crude product separated from cinnamon leaves. Then I want to identify, I want to confirm this crude product available cinnamaldehyde or not. The cinnamon available cinnamaldehyde. Then I want to confirm that. Then I want to get the A sample is the crude product. The C sample should be control one, should be purified cinnamaldehyde. That's why the purified one only one sample. The crude product has more compounds. That's why they have the A has more dots. Understood? Then if cinnamaldehyde is not present, no. If it is come like this, cinnamaldehyde is present. Why? The cinnamaldehyde distance is that. The cinnamaldehyde distance is that. That's the cinnamaldehyde distance. The cinnamaldehyde compound, the moving distance is that. Can you see same distance, one compound is there in the A sample as a, the same distance, with same distance, some compounds in the A sample also. Therefore, we can identify the cinnamaldehyde, we can identify A sample contain cinnamaldehyde, and other than A sample has more impurities than cinnamaldehyde. They are impurities. They are not cinnamaldehyde. They are not cinnamaldehyde. They are impurities. We don't know what are they. But we can confirm it has cinnamaldehyde. Okay, if it is the final observation came like this, baseline, solvent front line. This is our crude product sample. This is a C control sample. Think they are the crude product dots. They are the crude product dots. Then this is the control sample. Then is that available? If it is like this. Is this the cinnamaldehyde present in a solution or not? Not present. Why? This is this point level. This is this point level. This is a midpoint. Okay, no any point same distance with the C control sample. Therefore, it's not present in the crude product. Understood, Aman? But this one, it is same line. Okay, then I have given full note. You don't need to write anything. Better to draw a short note of this. Please draw a short note of this within 2 minutes quickly. These measurements terms very important. Okay, you can't use another measurement or terms. They are fixed values on and names. Completed? Okay. Okay. Now I have few questions. Actually, they are not my question. They are past A-level questions. Okay. There was a question: why this in the first step? Why this reaction chamber close and keep 20 minutes? What's the reason? In the first step, why this reaction chamber close and keep 20 minutes? What do you think? Why this reaction chamber close and keep 20 minutes? Quickly, reason, what do you think? I මෙතන close කරලා තියන්න 20 minutes. What do you think? Why? Write down like this. Write down like this. Keep 20 minutes. Sorry, not like that. 20 minutes keep by close. That's the reason. Write down like this. To saturate the, that's the answer. Okay. To saturate the solvent chamber, to saturate the solvent chamber by solvent vapor. That's the reason we need to close the solvent chamber and keep 20 minutes to saturate. What's the meaning of saturate? What's the meaning of saturate? What's the meaning of saturate? Okay. Saturate. Amai, what's the meaning of saturate? In your BST, I think you discussed about saturated soil. No? Saturated. No, not well mix. Not saturate mean not well mix. The saturated condition of the soil, yes, you discuss. What's the meaning of saturated? The saturated mean all compound, all space filled by the whatever compound. Okay, the as example, normally we discuss after rain, the soil is saturated. After rain, the soil is saturated. The meaning is all spaces except soil particle, all spaces between soil particle filled with water. That's the meaning of saturated with water of the soil. Okay, then in this solvent chamber, why this solvent chamber close and keep 20 minutes? To saturate, to fill the solvent chamber by solvent vapor. Solvent vapor fill or saturate. That's a perfect word. That's a perfect keyword. Saturate the to saturate the solvent chamber by solvent vapor. While it is saturate, what happens when we keep this solvent? chromatography paper, when we place the chromatography paper, rapidly the solvent is moving. If it is not saturated, we need to wait some time to rapidly the solvent we need to get up. That's why we use this method to close the keep 20 minutes close the solvent can. Have you got the reason? Have you got the reason? Okay, the second question was in the exam, while using baseline and solvent, while drawing baseline and solvent front line, while drawing solvent front line and baseline, what are the factors you need to consider? The first factor is baseline is 1.5 centimeter above the below end, and the 1 centimeter below the low upper end, that is the measurements of solvent front line and baseline that you can mention. The other thing is you need to use very thin pencil. They note down these important points. You can go to, after this part, you can go to all past paper questions. You need to use a very thin pencil, and while drawing the lines on the chromatography paper, we need to draw a very smooth lines. There is no any damage to the, we need to confirm there is no any damage to the paper. That's why with thin pencil using very smooth line we need to draw baseline and solvent front line. Okay, they are the factors you need to consider. The final question, after this final result, how we observe them? How we observe them? For observation process, for observation we can use coloring agents. Coloring agents. Coloring agent we can use. We can use lighting agent. Light we can use. Lighting agents. For observation process, we can use spreading agents. Spreading agents. Spreading agents. Spreading agents. At the final of this chromatography, I will give you what are the coloring agents, what are the lighting agents, what are the spreading agents. I will give you all. Up to now, remember like this. If I told everything now, it will confuse. Okay. Now, somehow these methods we can observe. Okay. Somehow this method we can observe. After observe, if it is same level, we can identify this compound. Okay, that's the all about paper chromatography. If you can understand this paper chromatography, don't worry about other chromatography type. They are like very simple. Okay, if you understand the basic concept of the basic steps of the paper chromatography, other steps are very, very simple. Okay, any doubt in paper chromatography? Any doubt? Next day we complete the lesson. Okay. Next day we discuss the if you understood the paper chromatography, the thin layer chromatography is within minute we can complete. But today I am not going to discuss that. Your job is complete the all steps. Remember all steps and this distance and terms in the paper chromatography. Then within 1 to 2 minutes you can remember everything in the thin layer chromatography TLC method. Only few steps difference. Okay, only few steps difference. If you want, you can read the note, but not compulsory. Complete up to now. That's my request. Complete up to now. If you want only, you can go for future things. Complete. You need to compulsory complete up to now. Up to now we completed. Up to paper chromatography from the beginning. Okay. From the beginning, go through again. Okay, that's all for today. Do you have any doubt from today's discussion? Today we completed extraction methods and we started identification chromatograph methods. Only one method we could complete. Next day we complete the lesson, and after that in the Monday class we discussed all exam questions of this lesson, and the week after next week we start industrial chemistry, our second unit. Okay. Okay, any doubt? No. Then work very hard this time, because this is the most valuable time in your life. Actually, these 2 months, the final 2 months, don't take anything. Try to complete everything within these 2 months. Then freely you can work in the final 2 months of the exam. Okay, good night.